SpaceX and Elon Musk are very reserved with their statements about the details on the construction sites. This applies not only to the launch tower with a catching arm, but also to the launch table. The dizzying tower stands at 475 feet tall, including the orbital launch stand, easily as tall as a skyscraper. It's a major milestone for the Elon Musk-led company. We've never been closer to the space company's long-awaited first test launch into space. It's also the best ever look we've had at SpaceX's vision for the future of space exploration, and space-based, long-haul transportation. To build a fully reusable launch system for its interplanetary Starship vehicle, SpaceX has had to solve technical challenges such as slowing the massive spacecraft down as it re-enters Earth's atmosphere near orbital velocities, but perhaps the biggest challenge, as always with rockets, is fairly mundane. Its mass. The goal with a rocket is to build the lightest possible vehicle with the greatest amount of performance. In theory it sounds simple, but in practice, containing volatile liquids at high pressures is anything but simple, and with a fully reusable launch system. SpaceX has the added challenge of building vehicles that can withstand the rigor of launch, perform in a vacuum, and then return screaming through the atmosphere to land back at sea level pressures. The need to build light, strong and adaptable vehicles sometimes leads to interesting design choices, and SpaceX orbital launch mount. Another reason is that Super Heavy booster does not have legs to land on concrete as usual. Its purpose is to reduce the overall weight, making it possible to carry more cargo and fuel to orbit and to Mars. So the design team came up with the idea of building a catch tower and also build orbital launch mount to place Super Heavy booster and support Starship to prepare for the next launch. What will be the dimensions of the orbital launch mount? On the construction sites in Boca Chica, everything seems to be huge. The largest building is the launch tower on the launch site and surpasses everything. A launch tower with a height of about 140 meters is able to catch the also huge booster of the Starship, besides the launch tower. The launch table is another important construction project that is being worked on day and night in order to be ready for operation at the end of September and beginning of November. The orbital launch mount consists of two main components, 6 columns and one orbital launch table. Hexagonal symmetry all the way down to the mount's foundation piling suggests that SpaceX's new Starship pad design will begin with the bare minimum needed for a sturdy launch pad. SpaceX may change the design for Super Heavy, but Starship's thrust section is attached to a skirt, with 6 strengthened sections that host landing legs and hold down clamps. The sheer heft of 2 meters 6 feet wide steel and rebar columns, filled with concrete and pilings at least as wide and more than 30 meters 100 feet deep, certainly hints at a final structure capable of surviving the fury of Starship's Super Heavy booster, and the upper part of the foot poles is being assembled by talented SpaceX engineers. In a different area, predicting both parts will be about 20 meters tall, and, according to my opinion, is about 12 to 15 meters. How does the structure, design and operation of each part of orbital launch mount? The 6 columns of the orbital launch mount have been filled with concrete and built into a solid hexagon. Next to the capture tower, now 6 of these steel tube components are holding the launch table. This 6 steel pipes, it is approximate dimensions, length 5 meters, diameter 2.4 meters. These clamps will make by stainless steel and be designed to be very flexible, activated by a remote control system. It will help to fix the Super Heavy booster when it is placed on the launch pad. At the same time, it is also very flexible while unfolding during Starship launch. One of the special design points of orbital launch mount are cutouts in the launch table for sound suppression water system. It will create a massive flow rate of 300,000 gallons water per minute. Super Heavy will be as tall as the entirety of a Falcon 9 or Falcon Heavy rocket, first stage, second stage, and payload fairing included. Powered by up to 33 Raptor engines, the Super Heavy booster will produce upwards of 72,000 kilonewtons of thrust at liftoff, 9 times the thrust of Falcon 9, triple the thrust of Falcon Heavy, and double the thrust of Saturn V, the most powerful liquid fuel rocket ever to reach orbit. Combined with Starship, the full stack will weigh roughly 5,000 metric tons fully fueled. Another effect that SpaceX may be aiming for here is to cool down the Raptor engines after a long flight. But there is an environmental problem, that is when water pour in and evaporate under the enormous heat of the engine exhaust. This makes up most of the huge exhaust plume. To do this water system, SpaceX must definitely install pipes and high-pressure pumping elements on launch table, But, how exactly Elon Musk's engineers designed and installed it is still a mystery. How does booster catching system could work in principle? Taking about launch towers, it is known by everyone in December by tweets of CEO Elon Musk. SpaceX's latest plan to increase the number of flights they can mount by drastically reducing turnaround time. The key to this was a new launch tower that would catch first-stage boosters after they return to Earth. This would forego the need to install landing legs on future Super Heavy boosters, and potentially future Starship to land on Moon and Mars. Musk shared this idea in response to a tweet made by an animator who goes by the Twitter handle EricX. We're going to try to catch the Super Heavy booster with the launch tower arm, using the grid fins to take the load. Saves mass and cost of legs and enables immediate repositioning of booster onto launch mount, ready to refly in under an hour. So Musk is promising a turnaround time of less than 1 hour now and has confirmed that future Starships will be retrievable using this same apparatus and others like it. This latter scenario is likely to occur if and when Starships begin taking passengers on point-to-point flights between major cities, a service that Musk has promised will be available once the Starship is cleared for commercial flights. In the same thread, Musk was asked if such a structure would ever be built on Mars, and if Super Heavy boosters might be built there for missions to the outer solar system. Yes, on both counts. That would be a great outcome for civilization, replied Musk. With orbital launch mount. So have you ever wondered how these two new designs work together? During an orbital launch attempt, a reusable Super Heavy first-stage booster will detach from the Starship, and come back to Earth for a vertical landing and splashdown in the ocean. In future flights, SpaceX wants to use catcher arms on the launch tower, to capture the descending first stage, after catching the Super Heavy booster. The 4 fins attached to its body will be released to prevent the first stage from falling. At the same time, it will rotate a distance, so that it can accurately place the Super Heavy in the correct position of the orbital launch mount. At this point, the clamps on the launch table adjust to fix the first stage, then the launch tower will release the booster's body, and rotate back to its original position. The Starship will then be installed and continue for the next launch. At the orbital launch mount, to put designs like this into practice, it would require years of refinement and experimentation, be rapidly inspected, refueled and launched again. Whether this all works out remains to be seen. SpaceX has tried many things in the past in regard to rockets only to discard these ideas. Thanks for watching this video, and it's a super interesting topic. If you like this, make sure to subscribe. If you have any crazy ideas about what we should cover in next video, please comment it below, and we'll see if we can get to it. So thanks again for watching and goodbye.